guys, how you all doing? I hope you all are fine. So recently one of my subscribers asked me to help him build a fire alarm circuit. He gave me some conditions for the circuit. According to his idea, there must be two indicator LEDs, a buzzer and an IR receiver in the circuit. The circuit should operate like this, that initially one of the LEDs turn on, and whenever the IR receiver notices any flame across it, the circuit turns on another LED and the buzzer also. So with this concept in mind, let's try to make it. So here's my final design. This design uses a Darlington transistor pair. I have used the most common 2N2222 NPN transistors, and you can use any NPN transistor of your choice. So first of all, here comes the power section. I have connected a 9V supply, an IR receiver, a red LED, a buzzer, a green LED, and two transistors. So first of all, under normal conditions, IR receiver detects no flame across it, so this part of the circuit deactivates and we are only left with the green LED. So initially only the green LED lights up, and whenever a flame interacts with the IR receiver, the internal PN junction of the IR receiver creates a voltage across its terminals, which results in the smaller current IB1. So when the current IB1 goes into the base of the first transistor, it creates IC1, which is equal to beta 1 times IB1, and when the current IB2 goes into the base of the second transistor, it creates the current IC2, which is beta 1 times beta 2 times IB1. Hence this current is 2 times more than IB1. When the current IC2 starts flowing through the second transistor, the red LED lights up, which also activates the buzzer, and hence turning off the green LED, because we have a greater resistance over here, which is 2 kilo ohm, and a smaller resistance over here, which is 100 ohm. So majority of the current passes through the red LED and the buzzer, and hence the green LED turns off. And when there are no flames detected by the IR receiver is forward biased, which makes the current IB1 equals to 0, and hence the red LED and the buzzer turns off, and again turning on the green LED. Actually, the IR receiver captures infrared radiations. Normally IR rays exist everywhere, but our IR receiver captures only the high intensity IR radiations. First of all, let me show you how an IR receiver works, and then with our hands-on theory, we will be able to make this circuit. Before looking for the components, let me inform you that this IR receiver can only supply currents up to some microamps, and please keep track of the polarity of the IR receiver, because if you accidentally connect the IR receiver in the opposite direction, it starts working like an IR LED, so you better keep a track on it. So to demonstrate how an IR receiver works, I will make this circuit on a breadboard. So here's my setup, which I have made to show you guys how an IR receiver works. I will use a 100-watt bulb as a source of IR radiations, which I made in one of my previous series circuit video. So I have connected all of the components for the circuit to check the IR receiver, and you can read the voltage across the IR receiver, which is currently 20 millivolts, and see how far it goes if I turn on the IR source. You see the voltage rises up to 9.8 volts, and if I turn off the bulb, the voltage will again go to 0. Now if I again turn on the IR source, the voltage again climbs up to 9.8 volts. So to make this project, we would need an IR receiver, 2 NPN transistors, some resistors specified by the circuit diagram, a red LED, a green LED, a buzzer, a 9V battery, and a barrel board. Let's do it. So after 20 minutes of soldering, I've made this circuit on a barrel board, and now let's test it with the 100-watt bulb as an IR source. Let me connect it first. So after connecting the circuit, you can see the green LED lights up. And what happens if I turn on the bulb? You can see the red LED turns on and the green LED turns off, and also the buzzer is buzzing. So this circuit is working as expected. Let me turn the bulb off. You can see the green LED again turns on. Let me show you a close-up of this circuit. And now let me show you its operation with the matchstick. now you understand how the circuit works, and now you're able to give protection to everybody from hazardous conditions. So it's 4 o'clock in the morning and I made this video for just you guys. Please give this video a big thumbs up and subscribe to the channel if you're new, and please tell me if you have any suggestions or any questions regarding this video. You may comment them down or text me on my Facebook page. I have uploaded the circuit diagrams on my page as usual, and the link to all the documents is in the description below. Until next time, bye.